So last time what we were doing was we were deciding what the ratio was for sine, cosine, tangent for a given triangle. So trig ratios, which is sine, cosine, tangent. And if I give you a triangle, let's say this is 2, let's call this 3 over here. 2 squared plus 3 squared is 4 plus 9 is 13. So C is the square root of 13. Okay, that's the third side. We'll call this my right angle here. Call this A and call this B. So if I give you the triangle, this was a super easy move. If I ask you what is the sine of A, angle A, sine stands for what two sides? My joke was, hey, don't you want to stay away from sin? If you want to stay away from sin, that's always opposite over hypotenuse. So looking at this triangle, if angle A is in this corner, the opposite of angle A, what side would be opposite of angle A? 2, 3, or square root of 13? Opposite would be 3. And the hypotenuse would be always opposite of my right angle. So that's going to be 3 over square root of 13. To continue this, I don't like leaving square roots on the bottom. So I'm going to multiply this by a square root of 13 to get rid of the square root. A square root of 13 times a square root of 13 is just 13 on the bottom. But you can't just change the bottom, you have to change the top. And that leads us to 3 square root of 13. Now, there's a fast way of doing this, and let me just show the fast way real quick. If you guys forgot, there's a trick to it. If I say 6 over square root of, let's say, 5. Since you don't want the square root of 5 on the bottom, you're going to multiply by square root of 5. Now, I want to show you the pattern. The pattern always, since you were going to multiply a square root by the same square root, that always just comes out. And the square root gets moved on top. Let me do that again. 13 over square root of 2. The fast way of doing this is we were going to multiply a square root on the bottom and on top. So we were going to get rid of it on the bottom anyways. So it's just 2. Freedom! And the square root goes to the top. Okay. Let's do one more. If I say 5 over square root of 3, this is simply 5 square root of 3 over 3.
Mr. Cole, can you do one where there's a number in front of the square root?
A number in front of the square root, not a problem. If I say 6 over 2 square root of 3, let's do this one. So you could multiply by 2 square root of 3. But why? Why do extra work? I just don't want the square root. So it turns out this is 6 square root of 3 over 2 times 3, because you got rid of the square root. Now to just show that in different color, I would write square root of 3 on top and square root of 3 on bottom. And these guys would give me just 3. And the square root goes to the top. Okay, let's do this again. 7 over 5 square root of, let's say, 10. Oh, and afterwards, you can reduce. Take a look. Isn't 2 times 3 6? That would just be square root of 3 when you reduce. Okay, same problem here. If I just want to get rid of the square root, it's just 7 square root of 10 over 5 times 10. Freedom! Can't reduce there. Someone asked me about what if there's a square root on top and bottom. Here's the square root on top and bottom. If I say square root of 2 over square root of 3. So remember, we don't care for square roots on the bottom. We don't like that. So let's just get rid of the square root on the bottom. A square root always multiplies a square root, so that becomes square root of 6 over 3. Take a look. A square root always multiplies into a square root. A square root times a square root is actually a square root of 9, which gives me 3. Let's try one more. 7 square root of 7 over square root of 5. So let's do it the long way. Square root of 5, square root of 5. It's okay to have square roots on top. We're not allowed to have square roots on the bottom. That's why I'm only getting rid of the 5 on the bottom. And that's square root of 35. And since there is no pair, we have a 5 and a 7. There's no pair there. We're stuck with square root of 35. Okay, let me throw in some numbers here. For the right, 2 square root of 6 over 4. Let's not do 4. Let's do 5 square root of 3. Okay, so if I multiply just by the square root, you could do a 5. It would just be more work for no reason. This would be 2 square root of 18 over 5 times 3. Well, I could simplify square root of 18. What numbers make up 18? 9 and 2. Can I take a square root of 9 or 2? Well, 9 is 3 and 3. So it's 3 times 2. Oh, that's right the other way. 2. We could bring out a 3. The leftover, this 2, poor sap, he's stuck inside, over 15. Oh, but if you want instead, if you're too lazy, you could say, hey, do the 3's divide out? Save yourself some time there. And we're left with 2 square root of 2 over 5. Such a messy game we play. Okay. I wonder if you guys need me to still make the video. You guys can just watch this video over again. Okay. If you still need me to make a video, please email me, okay? All right. So today's story is we're coming back up here to say, if you have the triangle, we could find the trig ratio, easy. If the triangle is given, we could find the trig ratio, easy. Now, we're going to be given some information. And here's my example. I'm going to be given this information. A point on the unit circle. Here's the point. It's going to be 2, 3. Point is 2, 3. Find the sine of theta. Okay, let's graph the point. The point is 1, 2, 1, 2, 3. Okay, that's my point. So what would I do to find the unit circle? Well, we'll find the sine of this angle. And this angle here is going to be this guy here. That is my theta. Now I want to show you something kind of cool about this, is that this is already a triangle. Can you guys see the triangle here? See, that's already a triangle. And the triangle is going to be rise, my y value is 3, and my x value is 2. Not only do we have this, I can find the third side. We did this before. 2 squared plus 3 squared is 4 plus 9 is 13. So C is square root of 13. Square root of 13. So looking at this triangle, now that I've drawn this triangle, what is the sine of this triangle? Remember, sine is opposite over hypotenuse. So the sine is opposite of 3, hypotenuse is 2. Done. What is the cosine of theta? Cosine is adjacent over hypotenuse. So this is going to be 2 over square root of 3, 13. And
for sine, the hypotenuse, you put the
I made a mistake. Oh my gosh, thanks. Yeah, sorry. I don't know why I did this. I'm sorry. You're right. This is 13. I made a big mistake. Sorry, folks. Can't edit that out. Too lazy to. Thank you for catching that. That's 13. I don't know why I did that. Opposite over hypotenuse, right? See, I should have labeled it. I should have labeled this as opposite. I should label this as hypotenuse and then adjacent. That would have saved me a lot of problems. Okay, just to rewrite this part of it, we don't like square roots on the bottom. So remember, we can rewrite this quickly as 3 square root of 13 over 3 on the bottom, 13 on the bottom. On the right, we can write 2 square root of 13 over 13 on the bottom. Okay. Now, to rewrite this idea of this unit circle, we're going to spin this around. And I'm going to write this a slightly different way. I'm going to say an x and y point on the unit circle is really cosine of theta, comma, sine of theta. That means this is your x value and this is your y value. Okay. On the unit circle, which means the hypotenuse is exactly 1. This is the funny part. That means the circle I'm drawing will always have a radius of exactly 1. Okay? I'll show you guys how this works a little bit more when we have more time. But what if I give you the point, this is my point now, 3 over 5, comma, 4 over 5. How would I label this triangle here? And we could say this point here is x 3 over 5. And y, this is 4 over 5. But I personally think that is too much work. I personally think that. I think this is too hard. So I'm going to give you another way. The cosine of theta is 3 over 5. The sine of theta is 4 over 5. Now, how are you not going to confuse that? How are you going to know x is always cosine and y is always going to be sine? Folks, if I am in this corner here, that's my corner, okay? Would the opposite be an x value or a y value? The opposite, isn't that a y value? That's why our y value here, opposite, is sine for us. How about this value here? Okay, this value here. Is that an x or a y? That's an x value, right? So isn't that also our adjacent? Adjacent is cosine. So adjacent is x. So cosine is x, and sine, opposite, is y. If wherever you're seated right now, I want you to look opposite from you. Do you see the floor or the wall? You see a wall, right? How about adjacent? What are you sitting on? What your feet are touching is the floor. That's our cosine. So our cosine is always our x value, and sine will always be our y value. Now, if I look at it this way, I want us to redraw this triangle. The triangle is opposite, adjacent, and hypotenuse. Now look here. Cosine is what side? Cosine is adjacent, isn't it? Is that a positive or negative adjacent to you? That looks like a positive adjacent, positive 3. What is the opposite over here? The opposite is 4. 4. So take a look what I'm doing here. I'm going to draw a triangle. And what is the hypotenuse? Hypotenuse is 5. 3, 4, 5. Now, how is this slightly different than this guy here? If I drew a circle out of this, please pay attention here. This is the crazy part. If I drew a circle out of this, would this circle be a radius of 1? Is that a unit circle? What is the radius of the circle I just drew? The radius is actually 5, isn't it? So the way we get from here to here is we divide everyone by 5.
The doctor's back there.
No, it's not.
Deanna, we passed La Brea way before.
My doctor's up here. I know where my doctor's
Oh,
at.
you said La Brea.
Okay, so here's what we do to get the unit circle. I want you guys to all be okay with this. The radius is 5. Everyone see the radius is 5? Now, how many of you guys like the 3, 4, 5 triangle? Was that hard? 3, 4, 5 triangle? Or would you guys like this triangle over here? The 4/5 and 3/5 triangle. If you had to draw a triangle, which one would you rather draw? I'm gonna ask you guys this. If you like the 3, 4, 5 triangle, please click yes in participants. If you like the 4/5, 3/5, 1 triangle, please click no in the participants. Yes and no. Okay, so far half of you guys, no, a fourth of you guys are saying that you guys like the 3, 4, 5 triangle. And you know what? I like the 3, 4, 5 triangle too. So thank you very much for your participation. So what we're gonna do, when we are given problems that look like this, we are not gonna write this. This is actually not helpful to me. We're gonna write it this way. Now that we have this triangle here, I can ask you what the sine, cosine, and tangent are because we have all 3 sides of a triangle. We can actually look at it up here. We would actually already know it. So I'm gonna ask you this question. What is the cotangent of this triangle here? What is the cotangent of this triangle here? Just look at the triangle. Cotangent is adjacent over opposite. If theta was in the corner, would it be hard for you to figure out which is your adjacent and your opposite side? Adjacent is 3, opposite is 4. Done. Would it be hard for you to tell me what cosecant would be? Cosecant is hypotenuse over opposite. Hypotenuse is 5, opposite is 4. How about secant? Secant is hypotenuse over adjacent. And that would be 5/3. My point is that once you draw the triangle, these problems actually become super easy. Once you can draw the triangle, I can find sine, cosine, tangent really easily. Now, what's gonna happen here is I'm gonna give you guys another problem and we're gonna try to figure this out. So here's my next example. Find the secant of theta for the point. The point is it's 2 over the square root of 13 and 3 over the square root of 13. Okay, that might be like, what the hell do you want me to do with that, Mr. Ko? Here is the first thing I want you guys to decide. This is my x and this is my y. This is my cosine. And this is my sine. Okay, make sure we're cool with that. My cosine and my sine. Okay. What does cosine stand for? That's adjacent over hypotenuse. Sine is opposite over hypotenuse. Draw a triangle in quadrant 1, 2, 3, or 4. In what quadrant is cosine positive and sine positive? Now, here is a fast, cheat way of doing things. Quadrant 1, 2, 3, and 4. If you remember before, when I drew this out, I included some extra notes on this. I said in quadrant 1, x's and y's are both positive, because aren't we up in this corner? If you remember, this is a fast way, okay? In quadrant 2, x's are negative, y's are positive. See, we went left and then up. X's go left and up are in quadrant 2. X's are negative, y's are negative, we're in quadrant 3. And in quadrant 4, x's are positive because we went right, but y's are negative. So if I give you this point here, would that be quadrant 1, 2, 3, or 4?
1.
1. X is positive, y is positive, isn't it? They're both positive?
Yeah.
Right here. Not only do we have a triangle, we actually have all 3 sides of this triangle already. First, cosine is adjacent, isn't it? So that's 2. Sine is opposite, so that's 3. And don't they both share the same hypotenuse here? They both
Yeah.
have the hypotenuse of square root of
13.
Thank you. Now, since we have the triangle drawn out, and I like seeing the triangle drawn out, we can say what's a sine, cosine, tangent, secant, cosecant, cotangent of this angle. Okay, so let's try it. The cosecant theta is hypotenuse over opposite. So given theta is in the corner, what's the hypotenuse? Square root of 13. What's the opposite? 3. So my goal for you guys is draw the triangle first just to get used to it. And then we can then solve it. Solve for what they're asking for. They're asking for secant. Secant theta, give me 1 second, is hypotenuse over adjacent. So that's going to be square root of 13 over 2. Now, you could also do this. Here's the super smarty pants way. Okay, super smarty pants way. If you know x is cosine, how is cosine related to secant? Isn't that just the reciprocal?
Yeah.
Just the reciprocal. I think Isabella saw that.
Yeah, that's what I was going to comment because that's why I raised my hand. Cause
You're right, 100%. Now, that is a fast way using identities. But if you want a practical way of doing it, that's really what it is. Because what if I ask you cotangent? Cotangent is actually, we can do it with identity, but drawing the triangle, take a look at it. Cotangent is adjacent over opposite, which makes it really easy to say that's 2 over 3. One of the identities that we'll be learning later is that tangent of theta is sine of theta over cosine of theta, and cotangent of theta is cosine theta over sine of theta. Just the reciprocal. This is what we call a quotient identity. It's just the division. So another fancy way of getting there, just kind of skipping ahead, the cotangent of theta, we said was cosine theta over sine of theta. Hey, this is cosine and this is sine. So we write 2 over square root of 13 divided by 3 over square root of 13. In algebra 2, you realize you don't like dividing fractions over fractions. So you can multiply by the reciprocal. This is really 2 over square root of 13 times square root of 13 over 3. See, that's the reciprocal. You flipped it around. The square roots of 13s divide out completely. And we're left with 2 over 3. All right, let's do another problem. Let's see, what is the sine of theta when we have the angle negative 48 over 73 and 55 over 73. Okay, in what quadrant would x be negative and y be positive? I'm seeing quadrant 2. See, this is your x and y value. Your x is negative and your y is positive. Now, please 100% be careful when we draw this out. Our triangles always have to fall back down to the horizontal. We never, ever climb and we stick on here. I call this koalaing. We never koala. Oops, that looks terrible. I haven't done this now. We never koala. Oops. We never koala our triangles. We're always on the floor, okay? No koalas. Okay, when I do this, take a look at what numbers I'm going to use. This is cosine, so that's adjacent over hypotenuse. Adjacent is negative 48. This is sine, that's opposite. Opposite is 55. And the hypotenuse is 73. Done. You have everything you need to know about this triangle. But, don't we have sine already? So whether you remember how to write it here or deal with it here, both of these are going to be easy for us. Well, what if I ask you, what is the tangent of the triangle? That's opposite over where theta is this corner here, right? It's going to be 55 over 48. This is our reference angle that we're using. This is the angle of theta, but we're going to use our reference angle in the corner. Say what's opposite and hypotenuse and adjacent. Okay. What if I ask you, what's cosecant? You could jump cosecant from here if you're good with it. If not, looking at the triangle, cosecant is hypotenuse over opposite. Okay, what about if I throw a bunch of square roots in this? Okay, let's see. Let me use this one. Here's your point. Negative square root of 46 over 9 and square root of 35 over 9. What quadrant would this be in? X's and Y's, where your X is negative.
Quadrant 2.
Quadrant 2, you got it. And the Y is positive? That's right. So I'm going to draw the triangle. Careful about how you draw the triangle. I always draw it away, facing away, facing away. Get away from me. So this is going to be your negative square root of 46. Opposite, that's my opposite because this is my sine. Square root of 35. And my hypotenuse is 9. Now I have all three sides. So if I ask you sine, cosine, tangent, no problem. If I ask you sine, this is going to be square root of 35 over 9, just like we were going to say here. That is cosine and sine. If I ask you tangent, it's going to be opposite over hypotenuse. I'm sorry, opposite over adjacent. Oh no, we have a square root. Nobody cares. Square root of 35, so yeah, times square root of 46, all over negative 46. Remember, you don't have to multiply the negative again, just get rid of the square root. Okay, and this is just some fancy number. You can multiply that out with a calculator. Okay, let's see, what if they're both negative? What if I gave you one that said, negative 7 over 25, negative 24 over 25, okay? Find the tangent of theta. Okay, we're gonna do this the long way, not the short way. by drawing the triangle. In which quadrant are they both negative? Careful. X is negative and Y is negative. Quadrant
Quadrant 3.
3, perfect, thank you. Right, so I actually drew it. I said X is negative and Y is negative. So take a look at how I'm gonna draw this triangle. The triangle is gonna go away. It's never gonna lean. You never lean on the Y-axis. You always go back to the horizontal. Remember how we said reference angle? That's my reference angle right there. So X is negative 7 over 25, and Y is negative 24 over 25. Oh, sorry, no fraction. Just the negative 24. So if I ask you for a tangent, that's opposite over adjacent. Opposite is negative 24. Adjacent is negative 7. The negatives cancel out, 24 over 7. Okay. Now the last part of this is we want to talk about, we have special triangles that we have to deal with. And the special triangles are these triangles here. We have special angles for us. That's going to be 30, 60, 45, and 90. 30, 60, 45, and 90. Okay, I'm going to draw these triangles for you. The 30-degree triangle, 30, 60, and 90. Okay, that's our 30-degree triangle. Our 60-degree triangle is standing very proud at 60, 30, and 90. It's really the same triangle, just tilted over. And our 45-degree triangle, 45, 45, and 90. Okay. Almost done, folks. Okay, 45, 45, and 90. And then our 90 degrees is because these are all 90, okay? These are because they're all 90. Okay, so 30, 60, 90, 45. So please see that these ratios will always be the same. The short side is 1. We double to become the hypotenuse, and the long side is square root of 3. The short side is always next to the 60. Looking at the next triangle, the short side is always next to the 60. 1, hypotenuse is double, square root of 3. And you guys will be using these triangles for your homework, okay? And last one, 45, 45, 90. That's going to be 1, 1, square root of 2. So when you're doing your homework, please have these triangles out. And also, the 90 degrees, I'll show this one more time in a little bit, okay? So I'm going to ask you this question. What is the sine of 30 degrees? Looking at this triangle, what would the sine be? The sine is opposite over hypotenuse. Opposite over hypotenuse. What is the cosine of 30 degrees? That's square root of 3 over 2. What's the tangent of 30 degrees? That's 1 over square root of 3, which can be rewritten as 1 square root of 3 over 3. What is the sine of 60 degrees? Okay. All right. The last thing is, so you can do the same thing for all this stuff. 45. Now, that's going to be opposite is 1. Hypotenuse is square root of 2, right? This was square root of 3 over 2. Okay, and that's the idea. Using these 3 triangles, you guys are going to do the second IXL, and I'm going to cut the IXL short. I'm going to make it to like 40, okay? Maybe even like 30. Now, what if I write it this way? What if I write this as sine of pi over 3. Isn't pi over 3 180 divided by 3 the same as 60 degrees? Yeah, so it turns out that's the same answer. If I write sine of pi over 6, 180 divided by 6, that's 30. Yeah, this is also 1 over 2. So whether I write it in degrees or radians, they should give you the same angle, okay? So we're gonna start off with these really basic ones, and then we'll work around the circle next time.